Hello students, welcome to Meetu maths classes. Your question number 6 is let A is a set 1, 2, 3 and B is a set containing 4, 5, 6 and 7 and let F is a mapping in which 1 is related to 4, 2 is related to 5 and 3 is related to 6. Be a function from A to B. Then you are supposed to show that F is 1, 1. Now to show a function is 1, 1. F is a function from A to B such that F is 1 related to 4, 2 related to 5 and 3 related to 6. Now to show this function is 1, 1, we are supposed to show that every element in the domain have distinct image in the codomain. So for this we can draw Venn diagram. Let F be a mapping from A to B, or it is a function from A to B. A is 1, 2, 3, B is 4, 5, 6 and 7. Now in this function 1 is related to 4, 2 is related to 5 and 3 is related to 6. Since every element of domain has distinct image in codomain, that implies since every element of domain has distinct image in codomain, therefore F is 1, 1, or we can say it is an injective function. Your question number 7 is, in each of the following cases, state whether F is 1, 1, onto or bijective. We know that a function is bijective if it is both 1, 1 and onto. So let us start with the first part, where F is a function from R to R defined as Fx is equals to 3 minus 4x. Now for this function you have to check for injectivity. Now for injectivity we are going to check that every element of domain must have distinct image in codomain. So let us take two elements in the domain such that their images are equal. Now we are going to show that the elements are also equal. Now fx1 is 3 minus 4x1 and fx2 is 3 minus 4x2, and this will implies that x1 is equals to x2. So if the images are equal, then elements are also equal. That must implies that your function f is injective or 1, 1. Okay. Now we are going to check for surjectivity. And for surjectivity, what we are going to show, we will take an arbitrary element in the codomain and we will show that there is a pre-image of that arbitrary element in the domain. So let us take an arbitrary element in R. This is the codomain, such that fx is equals to y. Now our purpose is to prove that this x lies in the domain R. So fx is equals to 3 minus 4x is equals to y, and that will implies x is equals to 3 minus y upon 4. If R is a real number, then 3 minus y is a real number, then 3 minus y upon 4 is also a real number. So that will implies that there exists an x 3 minus y upon 4 belongs to our domain such that fx is equals to y. for all y belongs to codomain. Okay. For all y belongs to codomain, there exists a pre-image in the domain, and that will implies that f is surjective or onto. Okay, and if f is 1, 1 and onto also, so 1 and 2 implies that f is a bijective function. Now we are going to check your second function for 1, 1 onto or bijection. Now to check this function for injectivity first. Now for injectivity, let us take two elements in the domain R such that their images are equal. fx1 is equals to fx2. So this will implies that 1 plus x1 square is equals to 1 plus x2 square, and 1 will cancel out. So this will implies x1 square minus x2 is equals to x2 square, or we can say that x1 is equals to either plus or minus x2. So x1 is not necessarily equals to x2. So this function is not 1, 1. And for example, we can take, consider f1, and that is equals to 1 plus 1 ka square, that is 1 plus 1, 2. And if we take f of minus 1, then this will also be equals to 2. And since we get two elements whose images are equal, but the elements are not equal, so f is not injective, okay, or 1, 1. And now we are going to check for surjectivity. And for surjectivity, we are going to check whether every element in codomain must have a pre-image. But if you observe the images of a real number, all the images of real number are positive. Since all images are positive, so in the codomain is the set of all real numbers. So all negative real numbers do not have their pre-image. That implies all negative numbers do not have any pre-image in domain. So your function f is not surjective or onto. And if your function is not injective, not surjective, so 1 and 2 will implies that f is not bijective. Okay. Your next question is question number 8. Let A and B be sets. Show that f is a function defined on A cross B to B cross A such that f of AB is equals to BA is a bijective function. So we are supposed to find that your f defined as f is a function from A to B such that, or we can say that f is a function from A cross B to B cross A such that f of AB is equals to BA. Now we are supposed to check this function for surjectivity, injectivity first. Now for injectivity, let us take two points, two elements A to B2 belongs to the domain A cross B such that their images are equal. F of A1 B1 is equals to F of A2 B2. Okay. Now F of A1 B1 is B1 A1 and F of A2 B2 is B2 A2. And if two ordered pairs are equal, that will implies that B1 is equals to B2 and A1 is equals to A2. And if these two are equal, then the ordered pair A1 B1 is equals to the ordered pair A2 B2. And if we take two elements such that their images are equal, then we have proved that the two elements are also equal. So this will implies that F is injective, or we can say 1-1. Now we are going to check for surjectivity. Now for surjectivity, let us take an arbitrary element in your codomain B cross A, that is the codomain, such that F of some element is this BA. Now we are supposed to check whether this XY belongs to A cross B domain or not. Now F of XY is YX, okay, and YX is equals to BA. Two ordered pairs are equal, that will implies Y is equals to B and X is equals to A. Or we can say that XY, the ordered pair XY is equals to the ordered pair AB. And if A belongs to A and B belongs to B, then AB belongs to A cross B. So we get an element XY, that implies there exists an XY that is equals to AB belongs to A cross B, that is the domain, such that F of AB is equals to BA for all BA belongs to B cross A. That implies your function F is surjective or onto, okay. And if your function is injective and surjective, so 1 and 2 implies that F is bijective.